2, 4 is about complex numbers. So first, let's review what the heck a complex number is. So remember, a complex number is of the form a plus bi. There is what's called a real part and an imaginary part. So I is that imaginary component. Remember that I is the square root of -1. Mathematicians were finding that this square root of a negative was happening, and they needed a way to deal with it. So they came up with the rules for I. So I is the square root of -1. And what's interesting about i's is if you square it, you get -1. So that means if you have 3 i's multiplied together, I cubed, you get -I, because it would be -1 times an extra I. And then if you have I to the 4th, it ends up being -1 times -1, or just 1. Now that's something that's kind of interesting, is if your power is an exact multiple of 4 on an I, you will always be the number 1. So I to the 8th is 1, I to the 12th is 1, I to the 16th is 1. Any power that is a power of 4 on an I is always equal to 1. If you have 3 extras, it'll always be -I after you take out all the I to the 4ths. If you have 2 extra, it's going to be -1. If you have 1 extra, it's just going to be I. So this little pattern continues eternally, forever and ever and ever, and never stops. The ones I want you to make sure that you know are these top 2. Those really are the most important ones to know, because those are the ones mathematically that are going to come up here and there depending upon what we're doing. So first, let's talk about adding or subtracting complex numbers. Now, if you're going to add or subtract them, you just treat the I like any other variable. You know, if that was a 1 minus 6x plus a 5 minus 2x, you guys wouldn't hesitate. You would just combine like terms. Well, that's exactly what you want to do here. There's no difference. So because it's a plus between them, watch, if that would be a minus between them, you would distribute that negative, but it's a plus between them. It's just 1 minus 6i plus 5 minus 2i, and combine like terms. Now, it is traditional to write the real component first, followed by the imaginary component. If you turn it, it's not a big deal to me, but just so you know, in case Alex would want you to have it in that complex number standard form. So if we combine our real components, 1 plus 5 is 6. And then treat your imaginary components like they're just any other variable. If I have -6i's minus 2i's, I have -8i's. So adding or subtracting them, very nice, good process, okay? Now multiplying them, you have to be a little more careful. And the main thing that's going to occur is you're going to get that I squared happening. So make sure you always know that I squared is -1. We usually don't multiply more than a pair of them at a time, but an I squared will probably come up. So let's look how we do this. If we're going to do this, we still have to follow our rules of distribution. So, you know, think about what we have done in the past. Your -1 distributes to both of those. Your 6i distributes to both of those. Initially, just treat it like any other variable, okay? So let's do that first. If I distribute the -1, I get +6 minus I. You could write -1i, that's okay. You don't have to. And then if you distribute the 6i, you get -36i plus 6i squared. So just treat it like it's an x, okay? The only thing to be concerned about is if within your problem you have an I squared, you have to replace it with -1. So that's really 6 times -1. So 6 times -1 is really -6. So it just changes the sign of anything that it touches. So an I squared becomes a -1 and multiplies by whatever it's on. So technically, and I'll write it over here, we have 6 minus I minus 36I minus 6. And now go ahead and combine those like terms. So 6 minus 6 is 0. A complex number in standard form, they might want to have you enter that 0. Just be careful. I don't know. Try it on Alex with the 0 and try it without. The i's, just treat them like normal variables most of the time. Negative 1 of them plus negative 36 of them is negative 37. So again, the 0 for me isn't necessary. I don't know if the 0 is necessary for Alex or not. So when it says this instruction, it makes me wonder if they want a 0 and an I, you know, like a number and an I. So just be careful, but that's your answer. Do we have any questions on those first two problems? Good so far? Okay. Okay. Now let's talk about something called the conjugate. Let's talk about something called the conjugate. Do you need to see it more? Are you guys good? Okay. The conjugate. That is A plus BI has something called a conjugate in A minus BI. Now, you may remember back in any type of algebra, A plus B times A minus B is A squared minus B squared. For conjugates, what's interesting is A plus B, I, times A minus BI doesn't become A squared minus B squared. It becomes A squared plus B squared. Now let's talk about why that happens. You end up with a minus B squared I squared. And what did we say an I squared does? It turns the symbol to whatever it's touching. So that minus B squared becomes a plus B squared. So it's just a little formula. You can physically do the FOILing and multiply it out, but no matter what, you'll end up getting that A squared plus B squared. You might notice that we don't have any I's anymore. So that's why conjugates are used, because we don't want square roots in our denominator. We don't even want square roots that have that negative in it. So when you see this problem here that says to divide the complex numbers, if it says to divide the complex numbers, this is what I want you to get in the habit of doing. Take and put parentheses around both pieces, okay? Now, we are only concerned with the fact that an I is in our denominator. It can be in the numerator. We don't care about that. So the 3 plus I is causing an issue. So for us to get rid of it, we're going to multiply by the conjugate, which is 3 minus I. So whatever you do to the top of the fraction, you're going to do to the bottom of the fraction so that things cancel out nicely, okay? So let's go ahead and do that distribution. Okay, so look, watch what happens. The negative 1 distributes. The negative 5I distributes. And then we'll do it on the bottom. 3 is going to distribute. And then positive I is going to distribute. Okay, so let's deal with the top first. If I distribute a negative 1, I get negative 3 plus I. If I distribute a negative 5I, I get negative 15I plus 5I squared. On the bottom, we're going to do the same. Distribute the 3, you get 9 minus 3I. Distribute the I, you get plus 3I minus I squared. So look what happens. On the bottom, the i's should cancel out because those middle terms are going to cancel. And what does an I squared become? Negative 1. And so this is really negative of negative 1, or the opposite of negative 1, which becomes plus 1, right? So the bottom is going to become 9 plus 1. Now let's deal with the top. We have that 5I squared, okay? I squared becomes a negative 1, changes the sign of whatever it's touching. So this is going to become negative 5. So we really have on top negative 3 plus I minus 15I minus 5. Let me make that look a little nicer for you here. okay? And now we're not done until we put our like terms together. The bottom should be able to be mushed into one number, and that's what we want. On top, if we put the real components, you usually should write those first. Again, I won't be as concerned. Alex might be. You're going to have negative 8 minus 14i over 10. Now, standard form of a complex number has the real component separated from the imaginary component. So that 10 under there is under both pieces. So let me show you how Alex will probably want it. Separate it, put the 10 under both things. Because it's under both, it's dividing into both. And then just reduce those fractions as much as you possibly can. What do you notice goes into everything? 2, right? We can reduce that by 2. So let's reduce that. So we get negative 4/5 minus 7/5 times I. So you'll notice we have a real component followed by an imaginary component. That's the one that has the I on it. So that is how they want that in standard form. So if you see this, yeah, they should reduce by 2, but don't leave that 10 under the whole thing. Separate it and then reduce it. Okay. Do we have any questions about how we divide a complex number? Okay. I'm going to make sure everybody's got that. Okay, so powers of I, we already talked about, but I want to put them down here. So I to the first is just I. Put my negative in the wrong spot there. I squared is negative 1. I cubed is negative I. I to the fourth is 1. Okay, so that pattern is what they're talking about in this next problem. So we're talking about that pattern there when we're talking about powers of I. So you'll notice that the pattern, okay, so let me just show you the pattern if we continued. I to the 5th is I to the 6th is negative 1, I to the 7th is negative I to the 8th is 1. I to the 9th is I to the 10th is negative 1, I to the 11th is negative I to the 12th is 1. Now I could keep doing that forever and ever and never stop. Those powers are going to repeat themselves. Every 4 has that same pattern. So in mathematics, there's a part of mathematics that you can study if you ever decide to torture yourself that way. It's called number theory. And one of the things they talk about is remainders when you divide. And so what you can think about is if you divide the power by 4 and you have no remainder, then it's always going to be 1. If you divide the power by 4 and the remainder is 3, it's always going to be negative I. If you divide by 4 and the remainder is 2, it's going to look like that. If you divide by 4 and the remainder is 1, it's going to look like that. And all of those things would do that. So here's the key to simplifying a power of I very, very quickly. Divide the power by 4. Now I am talking old school division where you have a little remainder down at the bottom showing. You know, I'm talking, you don't need decimals. I'm talking stop as soon as you get a remainder. Well, 4 goes into 32 8 times with a 0 remainder. A 0 remainder always means that the I to the 4th pattern hit perfectly so that it's really I to the 0. And what's anything to the 0 power? 1. And so what's the answer to this? It's 1. I to the 32 is 1. I to the 33 is I to the 34. So let me show you. If it was not 32, but it was 33. When you go to do that division by 4, the closest you can come is 8. What's our remainder? 1. How many i's are we going to have? One. So that's just an I to the first. You don't have to write the one, but so it's something called mod 4. You're always concerned in how many 4s are in there and what's your remainder. So I to the 33 is I to the 34 is I squared, or negative 1. I to the 35 is I cubed, or negative I, and I to the 36th is 1 again. So it just is going to keep cycling through that. So if you know how many 4s is in there, you take out those 4s, however many is left is your remainder, and that remainder will always be the i's. Does that kind of make sense how that works? It's just a pattern, and that pattern continues. You could say, I know right now, without even checking, that an I to the millionth power is 1. Why? Because 4 goes into a million perfectly. But 1,000,001 is I. 1,000,002 is I squared. 1,000,003, you get the idea. It's just following a pattern. So know your pattern, know this pattern, and really you just take that power, divide it by 4, whatever your remainder is kind of giving you the answer, okay? A little bit strange, but okay. So your homework is right here. So let's just discuss what's happening. For 1, 2, you're just combining like terms, adding up your real part, imaginary part, bam, okay. 13, 14, you're going to distribute. 16, you're going to distribute. Let's do 15 together, okay. Let's do 15 from the homework together. Multiplication is commutative. We can really do it in any order that we want to. I just, if I don't see any other pattern, I'm just going to kind of go from left to right. So 7i times 3i is 21i squared. But we just learned about i's. We never should have a power on an I. We know, hopefully, that I squared is equal to negative 1, right? I cubed is negative I. I squared is negative 1. So this is just negative 21. Now that we have that, now that that's mushed together, it became something nicer. Now we distribute that. So 21 times 8, 2 negatives make a positive, would be 168. 2 negatives make a positive again. 21 times 6 is 126, and then the I is there. That standard form for a complex number, because we see that real part, we see that I part, there's no powers on our I's, bam, we're done. Does that make sense how that one worked? So there's number 15. Then I would like to also do with you right now, number 1 and number 11, and then you'll have the rest of class to work on these. So everybody, let's look at number 1. Okay, so number 1, the bottom piece has 2 pieces to it. Put it in parentheses. Okay, so remember, we are going to multiply by the conjugate. The conjugate just changes that middle sign only. So multiply top and bottom by minus 4 minus 2i. On top, we're going to distribute. So that's going to be negative 36i, and then minus 18i squared. Let's distribute on the bottom. We're going to get 16 plus 8i minus 8i minus 4i squared. Okay, now remember, for this to be a conjugate, these should cancel out, which is exactly what happened. Those are opposites. They cancel out. The 4i squared, remember, an I squared touching anything changes its sign, because that's really negative 4 times negative 1. So this becomes negative 18 times a negative 1, which is a positive 18. So I'm going to write the 18 first. That's standard form for a complex number. And then I'm going to have 16 plus 4. 16 plus 4 is 20. So I am going to put the 18 over 20, the 36 over 20, and separate the I. Remember, a complex number standard form, we have the regular number, we have the normal number. So the 20 is under both. The 20 gets written under both. And then just simplify each one as much as you can. There's not much you can do. You reduce it a little. 18 and 20 are both divisible by 2. So bring it down a little bit. So that is 9/10. 36 and 20 are both divisible by 4. And so that's 9/5. And you can't go further. That is what it is. There is problem number 1 on the bottom, that division. Any questions about that one? Okay, now let's do 11, and then you're on your own to continue this process, okay? Okay, so now we're moving on to 11. 11 has 2 pieces in our numerator and our denominator, so put parentheses around both. We are going to multiply the bottom times the conjugate. We're going to use the bottom's conjugate. So the conjugate of 6 plus 9i is 6 minus 9i. And whatever we multiply on the bottom, you have to multiply on the top, or you have changed your fraction. So let's go ahead and do that distribution. If we distribute on top, so first let's think. We're going to distribute the negative 6. We're going to distribute the negative 2i. Let me show you what we get. We get 36. No, we don't. We get negative 36, positive 54i, minus 12i, plus 18i squared. On the bottom, we're going to get 36 minus 54i plus 54i minus 81i squared. Okay, so we have some things to do before we proceed on, okay? So here's the things we have to do. The I squared terms have to become the opposite of what they were. Remember, that negative 1 has to appear. So that's going to become a negative 18. This one's going to become a positive 81. And then another thing I think is easy to take care of at this spot is these 2 pieces are opposites. They should be. If you did a conjugate right, that will always happen. Okay. So on top, we have negative 36 plus 54i minus 12i minus 18. And on the bottom, we have 36 plus 81. And now it's just a matter of mushing stuff together. Negative 36 minus 18 is negative 54. 54 minus 12 is positive 42. That's got an I on it, so it keeps an I on it. And then 36 plus 81 is 117. Okay. Are we good? Is everybody with me at that particular spot where we're at? Okay. And then split it apart so it is in proper form. Um, 54 and 117 are both divisible by 3. I checked. Actually, I think they might be divisible by 9. Let me see here. Yeah, they're actually both divisible by 9. If you divide 54 by 9, you get 6. If you divide 117 by 9, you get 13. 42 is not divisible by 9, but it is divisible by 3. 42 divided by 3 is 14. 117 divided by 3 is 39. Okay, so that is your complex number stuff. So for the rest of class, work on this assignment. Do we have any questions? Yes. Yeah.